Okay, here we go. Next part, density. Density is going to be, in your own words, what is the definition of density? It's basically, in my own words, yours could be different, how much stuff is in a space. The more stuff you have, or the leisure space you have, that is it. So much stuff you have in space. The stuff we're talking about is usually going to be like mass. Okay. In the space we're talking about is volume. Can we see that on the screen? Yeah. Okay, volume. So how much mass is in a volume? So how do we formulate that? How do we express that in numbers? Mass divided by volume. Density is equal to mass over volume. All right, and that's going to be your labels. It's going to be some type of mass or some type of volume. Volume is going to be some type of grams. Volume is going to be some type of liters or cubic centimeters, stuff like that. Keep those in mind. Flip the page over. Here we go. So if we're using that formula, D is equal to M, density is equal to mass over volume. How do we rearrange that? How do we solve for mass? Well, move the things over. So mass is equal to density times volume. And if you want to get even further, volume is equal to, which is kind of a tough rearrangement for some people, mass over density. So there's your rearrangements in the formula. Mathematically, if you don't know those, I'd write those down. All right. So if we have a graph here, and we know what our formula is, mass over volume. So if we have a graph of mass versus volume, so here's mass on the y-axis, and here's volume on the x-axis. If I just take mass divided by volume, I got the density. So looking at this graph, how do we read graphs? Let's check it out. All right, so from the graph, the first one for part A says the mass of 8, says from the graph, the mass of 8 centimeters of metal A. Okay, so I go to 8 centimeters. Let's see, 6, 7, 8. Going up to metal A, which is that first line. Then we go over, we look over. Oh, it's about halfway. So I would say 10, 20, 30, 40. So I would say it's probably about 45 grams, roughly. It's about in the middle. I'd go in the middle. You could say 44, you could say 46, but I'd say right about 45. So that's how you read those graphs. You go doom, doom. Look at the graphs that way. Graphs are always going to run into these ACTs, everything, so make sure you know how to look at graphs. Check out the next one. For part B for the graph, the volume of 70 grams of metal B. So we go to 70, 60, 70, move it over, see, whoosh, it's right on this line, right about there. Then we go down, ooh, not quite 9, but a little further, so I would say that would probably be about, where are we at? I would say about 8.8-ish, and that's going to be in cubic centimeters. All right, so this line down, about 8.8. You could say 8.9, that would be good. So where do I determine this stuff? Okay, so you mark that on the graph. That's the next part, so I go, this is where I determined A, because I went like that. Here's where I determined B, like that. So use the density of B as a factor to determine the answer to B. Show your setup. Okay, so what this is saying, and this is kind of a weird wording, and I probably didn't word it too good, but what it's saying is, how can you calculate this? All right, how can you calculate the density of B? Show me the setup. So here's metal B. So remember, formula for density, mass over volume. What's my mass? Well, the mass is 70 grams. So 70 grams divided by 8.8 cubic centimeters. There we go. That's how you figure it out. All right. That's how you figure out the density for it. All right. So that's how we figure out density. So that. So we go here. 70 divided by 8.8 gives me 7.9545. Okay, that's my calculator answer. This is unrounded. Think about what we got to do for rounding. one significant figure, two significant figure, one significant figure wins. So really the correct answer is 8 grams per cubic centimeter. That is one significant figure. All right, so that's how you figure out the density. And there you go. That's how you figure that stuff out. Now, how could I figure out, let's say I didn't know, with these numbers, let's say I didn't know the grams. How would you set that up? Well, just plug it into the other formulas. All right? In other words, I have the density and I have the volume. How do you solve for mass? If I had density and I had the mass, how do you solve for volume? You should be able to show me mathematically how that sets up. Should. All right? So let's try some other problems with density. Looking at this next page. It says ethanol has a density of 0.789 grams per cubic centimeter. Show the mathematical setup. So what's the mass? So I'm solving for mass. So think, how do I solve for mass? Mass is equal to density times volume. So mass is equal to 0.789 grams per times 225. Now notice, mass is going to be measured in grams. Notice how the volume cancels out. All right. And by the way, 3 significant figures, your answer should be rounded to 3 significant figures, if you did it right. So what's the volume if you have 75 grams? So think, volume is equal to mass over density. So volume is equal to mass, 75.0 grams, over density, which they give you, 0.0789. This is grams per cubic centimeter. And really what you're doing here, the grams should cancel out and you're left with your volume, cubic centimeters. This divided by this, no, it's 3 significant figures. This number should be rounded to 3 significant figures. And just something to kind of side note, which is always kind of nice. The density of pure water is about 1 gram per milliliter. Okay? What does this mean? A lot of you guys see this grams per milliliter. Like, what does it mean? This means that I have this many grams and this many milliliters. So this means I have 1 gram in 1 milliliter of water. So if this was 2, let's say, for example, if this number was 4.5 grams per milliliter, this means I have 4.5 grams in 1 milliliter of water. This is per milliliter, like miles per hour. Realize what this label is telling you. All right. So with that being said, we got a couple practice problems to do. Try the practice problem. This is where you stop the video. At least try setting them up. Maybe don't do it mathematically, but at least try setting them up. And then once you come back to it, check your answers, and I'll go through it right now. So stop the video, check it out, let's see how you do. So here we go. Let's try a couple. Remember, our density is mass over volume. It says a ring supposedly made of pure silver has a mass of 20.44 grams. When this volume is taken by water displacement, it is found to have a volume of 1.95. Calculate the density. All right, so density is equal to mass over volume. 20.445 grams divided by 1.95 milliliters. There's my setup. Plug it in your calculator. 20.445 divided by 1.95 gives me a calculator answer of 10.4846 and a bunch of other stuff, but we're going to go there. So now, this number has how many significant figures? And if you said 5, you're right, because the sandwich 0 counts. This number has 3. 5 and 3. Remember, the lower significant figures matter. So I have to round this number to 3 significant figures. 10 to 0 to 4. Look at the 8. Oh, I round up. 10.5 grams per milliliter. Oops. Is my correct answer. That's how you work those problems. All right, let's try another one here. Based on the actual density of silver found on reference table S. Reference table S, we can look that up. Okay, that's not a big deal. So if you look up what the density of silver is, you can figure it out. So let's do the mathematical setup. So density of silver, find it, and could this ring actually be made of silver? Explain. So basically, let's say if silver's actual density was 2, okay? Let's say silver's density Let's say it's equal to 2 grams per milliliter. Well, obviously, this is not silver because these numbers don't even match up. So that's what you got to do. You got to explain. Once you find this, it's not in reference table S. Just look it up on the internet, on Google or Yahoo or the World Wide Web, whatever you want to call it. Once you do that, you can compare them and then tell me why. Don't just tell me, oh, they don't match. Tell me, well, it has to be a different metal or you're being played for a fool. And we'll talk about that in class a little bit too. All right, so there's density a little bit. Hopefully that was familiar. We'll keep moving on. Hopefully see you in the next video.